I feel privileged to extend my warm welcome to all presented here for the World Water Day celebration. World Water Day is celebrated on the 22nd March of every year. Water is one of the necessities of every living being on this planet. The value of water is multidimensional and beyond its price. It has a complex value with regard to our household, food, health, hygiene. So, without a true understanding of the value of water and importance of raising awareness about freshwater usage, we will not be able to safeguard this critical source for the benefits of everyone. The major two serious issues which cause freshwater scarcity worldwide is global warming and overusage. Therefore, in this session, we have an opportunity to learn about water-related issues and how to overcome it. Okay, now without any further delay, I would like to call a student of first year MBBS, Ms. Dishana K, to deliver a first presentation of the day about water necessary for life, moderated by Dr. J. Shivakumar Sir, as Associate Professor in the Department of Biochemistry. Up to you, Ms. Dishana.
Thank you, ma'am. Very pleasant good morning to one more present here. I'd like to thank the Biochemistry Department for giving me the opportunity to present on the topic, Water Necessary for Life. I'd like to start off my seminar with a quote. Water is life's matter and matrix, mother and medium. There is no life without water. So what is water? It's a substance that is composed of chemical elements of hydrogen and oxygen that exist in gaseous, liquid, and solid states. It's one of the most plentiful and essential of compounds. It is tasteless and an odorless liquid at room temperature. It has the important ability to dissolve many other substances. So how do two gases combine to make liquid water? Hydrogen and oxygen atoms are attracted by positive and negative charges. This thwarts the random movement that would keep them as gases. Hydrogen and oxygen atoms are attracted to one another by electrostatic forces between their positively charged protons and negatively charged electrons. This chemical bonding isn't very strong, but it is enough to overcome the random motion that the atoms undergo at temperatures between 0 to 100 degrees Celsius that would otherwise keep them as separate gases. So as a result of this, pairs of hydrogen atoms team up with individual oxygen atoms in a relatively dense but loose arrangement of water molecules that we call liquid water. So what are the properties that exactly make water so necessary for life? First, water is a universal solvent. As a polar molecule, water interacts best with other polar molecules such as itself. So this is because of the phenomenon wherein opposite charges attract each other. So because of each individual water molecule, it has both a negative portion and a positive portion. Each side is attracted to the molecules of the opposite charge. So this attraction allows the water to form strong connections called bonds. So this bonding makes water molecules stick together in a property called cohesion. This cohesion of water molecules helps plants take up water at their roots. Cohesion also contributes to water's high boiling point, which helps animals regulate their body temperature. Water as a solvent. So water's extensive capability to dissolve a variety of molecules has earned it the designation of universal solvent. And it is this ability that makes water such an invaluable life-sustaining force. Water's role as a solvent facilitates the transport of molecules like oxygen, carbon dioxide, and so on for respiration, and has a major impact on the ability of drugs to reach their targets in the body. The next important property of water is that it supports cellular structure. So water, as we all know, the major constituent of cells is water. So water allows everything inside the cells to have the right shape at the molecular level. As shape is critical for the biochemical processes, it is also one of water's most important roles. It contributes to the formation of membranes that surround the cell. So this is a hydrated cell on the left and a dehydrated cell on the right. As we can see, the dehydrated cell, as it lacks water, it loses its shape. So what water does is it creates a pressure within the cell that helps maintain its shape. As we can see, the hydrated cell on the right, the water within it pushes outward, and the cell maintains the round shape. In the dehydrated cell, as water is less, there's less water pushing outward, so the cell becomes wrinkled. Next, ease of movement of water molecules through biological membranes. So particles such as some ions and molecules need to be able to move around in biological organisms. One way in which this happens is in solutions. Example, the transport of oxygen in blood around the vascular system. Movement of solutions within defined channels such as blood vessels, lymphatic vessels, is easily explained by the comparison with, for example, the movement of fluids along pipes. So, and some ions and molecules in biological organisms also need to be able to move through tissues and membranes. For example, cell membranes. They move by the processes of diffusion, osmosis, and active transport, of which osmosis is the diffusion of water, an important process in living organisms. So now the thermal properties of water are also well suited to support life. Compared with other molecules, water can absorb and release a large amount of heat energy while only adjusting its own temperature by a very small amount. So this property helps water, it accounts for a significant proportion of body mass, which helps the body cope with the environmental temperature variations and helps the body maintain the temperature within a safe and comfortable range. Thus, the evaporation of sweat from the surface of the skin is very helpful in helping the body cool down, as it removes relatively large amounts of heat from the body as the sweat evaporates. So now we come to a question: why exactly is water necessary for life? All known life needs liquid water to function properly. It is essential in part because water is such a good solvent, readily dissolving and transporting nutrients across a wide range of temperatures. Drinking water is essential to keep your body functioning properly and feeling healthy. Nearly all the body's major systems depend on water to function and survive. Water also has an important structural role in biology. Water helps fill the cells to maintain shape and structure, as we have discussed before. In addition to influencing the overall shape of the cells, water also helps impact some fundamental components of every cell, which is DNA and proteins. Water makes up about 60 to 75% of the human body weight. So a loss of just 4% of total body water leads to dehydration, and a loss of over 15% can be fatal and can even lead to death. All oxygen-dependent organisms need water to aid in respiration process. As we've discussed, water is needed. As water is an essential component of blood, the carbon dioxide and oxygen has to be dissolved in blood for it to be able to be transported to the lungs. Other organisms also require water to break down food molecules or generate energy during the respiration process. In summary, water helps regulate the body temperature. It keeps the eyes, mouth, and nose and internal organs moisturized, hydrated, and helps protect the cells. It carries nutrients and oxygen, provides lubrication to the joints, and acts as a solvent to dissolve nutrients and minerals. In conclusion, water has the ability to retain a good amount of energy with only little fluctuations in its own temperature. It maintains our body temperature. It also helps in washing away the toxins from our body through urine. Reactions taking place inside the cell occur between substances that are dissolved in water. Water also helps in transporting substances in dissolved form in the body. Thank you.
So thank you, Dishna. Wonderful presentation. Just I want to add a few points regarding this water necessary for life. Few biochemical points I want to add. 1 gram of carbon dioxide will, 1 gram of carbohydrates will produce 0.6 ml of water, and 1 gram of protein will produce 0.4 ml of water. 1 gram of fat will produce 1.1 ml of water, and 1000 kilocalories on oxidation of foodstuffs, it will produce 125 ml of water. About the basic terms, you have mentioned about osmolality, which is defined as the osmotic pressure which is exerted by number of moles per liter of solvent, And osmolality is the number of pressure exerted by the number of moles per kilogram of solvent. Apart from that, albumin also plays an important role in maintaining the hydrostatic pressure and oncotic pressure. So if this gradient is disturbed, it will result in edema. Otherwise, it was a very wonderful presentation. Thank you, Dishna, for your active presentation. Thank you.
Thank you, sir.
Thank you, Dishna, and thank you, sir. That was informative. Now I would like to call upon a student of first year MBBS, Abhiram Bodapalli, to deliver a presentation about biological roles of water, moderated by Dr. I. Vijaypriya Madam, Associate Professor in the Department of Biochemistry. Up to you, Mr. Abhiram.
Very good morning to one and all present here. I am Abhiram Bodapalli. I sincerely thank the Biochemistry Department of the Lakshmi Srinivasan Medical College for providing me with this prestigious opportunity today. On the occasion of World Water Day, my topic for today's presentation at this consortium is the biological role of water. So the objectives for today's presentation are introduction regarding and then about Water Day, importance of water, diseases related to water, global water problems, and what we can do to help. So, as we know, water is made up of 2 hydrogens and 1 oxygen molecule, and then it has various chemical and physical properties that make it very important. The amphoteric nature, the self-ionizing nature, and polar nature provide a very important basis to the importance of water. And water, yes, ma'am?
Sorry to disturb you, Pa. Switch on the video, switch on the camera. Go ahead, Pa.
So the physical properties of water. So water is colorless, odorless, and then it exists in 3 forms easily, that is liquid, solid, and gas. And we also know that water can exist as D2O, that is deuterium, or heavy water, which is a common byproduct of nuclear reactions. So when we see the global distribution of water, there is 97% of total water source is salt water, and it can't be used for day-to-day purposes. And then 60%, and then out of the remaining 3% of water, which is fresh water, 69% is stored in glaciers and ice, and 1% is there at the surface, and 30% as groundwater. So Water Day. So Water Day was first formally proposed in the Agenda 21 of 1992 United Nations Conference on Environment Development in Rio de Janeiro. In December 1992, the United Nations General Assembly World Water Day is an annual United Nations Observance Day held on 22nd March that highlights the importance of fresh water. So this day is usually used to advocate for sustainable management of freshwater resources. And the theme for each day focuses on topics relevant to clean water sanitization and hygiene, which are WASH. And every year, each day helps with targeting the sustainable development of water goal. So the theme for this year is groundwater, making the invisible visible. So moving on, we are seeing the chemical properties of water. So the main chemical properties of water are the polar nature. And because of this polar nature is due to the presence of polar covalent bonds in the water molecules. And it is a universal solvent. And the cohesive and adhesive properties of water are very important in water movement in the body. And it also acts as an insulator, which helps in maintaining the temperature of the body. So moving on, we'll be seeing the main topic for today, that is the biological importance of water. As we know, water makes up 60 to 70% of the human body weight. It's a universal solvent. It supports cellular structure, maintains homeostasis of the body, and plays a role in the ionic concentrations, helps in production of saliva, and excretion is also a very important role. So water, a universal solvent. Why is it important? So water has an extensive capability to dissolve a variety of molecules and transport them. So this is what makes it an invaluable life-sustaining force. On a biological level, this importance is illustrated by transportation of substances like oxygen and nutrients. So water-based solutions like blood, CSF, and other sources help carrying water molecules to necessary locations. It also plays a major role in transportation of drugs to various targets and helping in treatment of diseases. So the next topic is the importance of water in maintaining the cell membrane. So water contributes to the formation of membranes and this happens by the rearrangement of phospholipids. We know that the phospholipids have two distinct components, that is the polar head and the non-polar tail. And due to this, what happens is, as we can see in the picture here, the hydrophilic head is oriented in such a way that it faces outwards, and the hydrophobic tail is facing inwards. So this helps in maintaining a non easily disruptible cell membrane. And the importance of this cell membrane is the presence of structure, and without proper membrane structure, the substances in the cell are not maintained properly. So the next one is the maintenance of cell shape. Flow of water across the membrane is made possible by intrinsic permeability of the membrane and the presence of aquaporins. And this is vital and an essential process in many key aspects of the human body, that is kidney water reabsorption, cell volume regulation, cell cytoplasmic ionic balance, and cell motility. So the water flow across the membrane is driven by both hydrostatic and osmotic pressure differences. And when this membrane is not flexible and is not mechanically constrained, it is displaced by the water and such a way that it moves in the opposite direction of water flux. So this membrane movement, which changes the overall cell shape, can occur locally or globally, depending on the spatial arrangement of the osmotic gradients. And in recent studies, it is shown that the water flux during cell development, that is during cytokinesis, this helps in the change of the cell shape, which is very essential in the process. Next, we have the buffering action of water. So water buffer cells from dangerous effects of acids and bases. And so the mechanism of how water acts as a buffer, it is a chemical process. So how this happens is, water molecule gives up a hydrogen and becomes OH minus, and this acts as a base. Or the same water molecule accepts hydrogen and becomes H3O plus, and this acts as an acid. So this adaptability allows the water to combat drastic changes of pH due to acidic or basic substances in the body. And this is the buffering action. So here we have a schematic presentation showing how this actually happens. So the next biological role is temperature control. So water has few characteristic properties such as high heat capacity, high heat of vaporization, and then the high density and freezing properties of water, and high heat of fusion. So these properties contribute towards water having a resistance to change in drastic changes in temperature. So this coupled with high presence of water in the body, that is 70 to 95% of a typical cell contains water. So these both these both properties together give the cell homeostasis. So apart from these biological roles, water also has different other roles, that is drinking and watering plants, personal hygiene, and recreational activities like swimming pools, water theme parks and beaches, and extinguishers, supporting aquatic life, agricultural purposes, and electricity generation. So now we're going to see the diseases related to water. So first we have water-borne diseases, that is infections that spread through contaminated drinking water. The examples of this is diarrhea and typhoid. And then we have water-washed diseases, which is basically sanitation issues. For example, ascariasis and encyclotomiasis. And then we have water-based diseases, that is infections transmitted through an aquatic invertebrate organism. For example, we have bilharzia, which causes schistosomiasis, and water-related vector-borne diseases. These diseases are transmitted by insects that depend on water for their propagation. For example, malaria, lymphatic filariasis, and onchocerciasis. So apart from this, we have well-known diseases that is caused by disruption in homeostasis, that is overhydration or water intoxication, dehydration, edema, diarrhea, vomiting, polyuria, oliguria, anuria, and diabetic insipidus, and syndrome of inappropriate anti-diuretic hormone, that is SIADH. So the main goal of Water Day is to reduce the global water problems. So what are the common global water problems? The common global water problems are water scarcity, water pollution, contamination, water-related diseases, poor infrastructure for water access, droughts, saltwater intrusion, and groundwater depletion. So there are numerous global initiatives for battling these issues, which are being run at a very huge global scale. But we ourselves can observe and follow certain actions in our day-to-day lives that would contribute to elevating and helping towards these problems and causes. So a few things which we can do is we can have a judicial distribution and usage of water. We can spread awareness about water crisis. We can recycle water whenever and wherever possible in our households. And we can have better managing agriculture, construction, and other sources of water consumption. And we can evolve proper infrastructure for sanitization and distribution of water. We can follow sustainable water development practices and combat climate change. So thank you for giving me this opportunity.
Thank you, Dr. Abhiram Bodapalli. This was a confident and informative presentation. Okay, you have enumerated all the biological roles inside the body and in the environment. Everything you have enumerated. Okay, and also you have also explained about the disorders related to body water homeostasis and also water-borne diseases, etc. Okay, this was nice presentation. Intramolecular bonding and intermolecular bonding, okay, that is responsible for majority of biochemical functions of water. Okay, if it should be said in simple words, means நீரின்றி அமையாது உலகு. Okay, nice presentation by you. Okay, next we'll move on to the next session.
Thank you.
Thank you, Abira. Thank you, ma'am. Next, I would like to call upon another student of first year MBBS, B. Suzanne, for presentation under the topic of Water, Molecules of Life, moderated by Dr. N. Navita Lakshmi Madam, Associate Professor in the Department of Biochemistry. And up to you, Suzanne.
Good morning, all. Water, the molecule of life. The Lord Almighty created the beautiful planet with so much care. You can just notice how intricate and detailed his creations are. The clear blue skies, the lush green forests, and the still waters. We can just go on and on about his creations. One unique thing he gave to this earth is water. Water, the elixir of life. Water is the driving force of all nature. 1/3 of the earth is covered in water, giving earth the name the blue planet. Life originated on water and is dependent on water too. Water is directly and indirectly linked with our survival. One could no longer live without water for more than 3 days. The earth's activities, the life of plants and animals, are dependent on water. 76% of a human is water. Water is the biological medium on Earth. The abundance of water is the main reason that the Earth is habitable. Most cells are surrounded by water and are made up of 70 to 95% of water. All living organisms require water than any other substances. Chemistry of water. Water molecules are made up of 2 hydrogen atoms and 1 oxygen atom. These atoms are of different sizes and charges, which creates the asymmetry in the molecular structure and leads to strong bonds between water and other polar molecules, including water itself. As a polar molecule, water interacts the best with other polar molecules, such as itself. This is because of the phenomenon wherein the opposite charges attract each other. Because each individual water molecule has a partial positive charge and a partial negative charge, and the difference between these 2 charges is called polarity. Each side is attracted to molecule of opposite charge, and this attraction allows water to form relatively strong connections called bonds with other polar molecules around it, including the other water molecules. Intermolecular bonding in water is strong, which adds up to its high boiling point. The 4 emergent properties of water which contributes to Earth's sustainability for life. They are the cohesive behavior, expansion upon freezing, ability to moderate temperature, and its versatility as solvent. The polarity of water is responsible for the fundamental basic properties of water. The unique bonding in water makes water molecules stick together in a property called as cohesion. Cohesion contributes to water's high boiling point, which helps animals regulate their body temperature. The high heat of vaporization provides animals with an efficient cooling mechanism. As we sweat, the body heat vaporizes water and cools the body surface. Evaporation of water from the leaves of plants cools their surfaces too. Another important physical property of water is adhesion. This process happens because hydrogen bonds are special in that they break and reform with greater frequency. This characteristic of water molecule is responsible for the capillary action, that is, the ability of liquids to flow against the gravity in a narrow space. Example, blood flow through the narrow capillaries. Water's role in drug metabolism. An individual's hydration status can be affected by medications that have the potential to alter thirst sensation, leading to decreased fluid intake, and diuretics, which lead to increased urine output. It is important for individuals taking these medications to be aware of how they may affect the hydration status of the body. Water's high surface tension. Surface tension, it is a measure of how hard it is to break the surface of a liquid. Expansion upon freezing. It is one of the important quality of water. The fact that water expands when frozen is really important for the life on Earth because it expands, ice takes up more space than water. This causes the ice to float on water, though it may be hard to imagine. This layer of ice actually helps to keep fishes and other living organisms warm inside the water bodies. If the ice were not there, many of these organisms would freeze to death. Water, the universal solvent. Water's extensive capability to dissolve a variety of molecules has earned it the designation of universal solvent. It is the ability that makes water such an invaluable life-sustaining force. On a biological level, water's role as a solvent helps transport and use substances like oxygen or nutrients. Water-based solutions like blood helps carry molecules to the necessary locations. Thus, water's role as a solvent facilitates the transport of molecules like oxygen for respiration and has a major impact on the ability of drugs to reach their targets in the body. Water can also dissolve compounds made up of non-ionic polar solvents. Even large polar molecules such as proteins can dissolve in water if they have ionic and polar regions. Biological chemistry. Most biochemical reactions occur in water. Chemical reactions depend on collisions of molecules and therefore on concentration of solutes in an aqueous solution. Water and its role in cell biology. It helps in maintaining the shape and structure of the cell. It is one of the critical biochemical processes of water. This is how a hydrated and a dehydrated cell looks like. Water's role in protein structure. Proteins are produced as long chains of building blocks called amino acids and needs to fold out into a specific shape to function properly. Water drives the folding of amino acid chains as different types of amino acids seek and avoid interacting with water. Water ordering around the hydrophilic molecules is one of the driving forces for the protein folding and formation of functional multiprotein aggregates. Water molecule surrounds DNA in an ordered fashion to support its characteristic double helix conformation. Without this shape, cell would be unable to follow the careful instructions encoded by DNA or to pass the instructions on to the future cells, making human growth, reproduction, and ultimately survival feasible. Chemical reactions of water. Water buffers cells from dangerous effects of acids and bases. Highly acidic or basic substances are corrosive to even the most durable materials. This is because acids and bases release excess hydrogen or take up excess hydrogen respectively from the surrounding material. Losing or gaining positively charged hydrogens disrupt the structure of molecules. As we have learned, proteins require specific structure to function properly, so it is important to protect them from acids and bases. Water does this by acting both as an acid and a base. Although the chemical bonds with water molecules are very stable, it is possible for water molecule to give up hydrogen and become hydroxide ion, and thus acting as a base, or accept hydrogen and become hydronium ion, thus acting as an acid. This adaptability allows water to combat drastic changes of pH due to acidic or basic substances in the body in the process called buffering. Ultimately, this protects proteins and other molecules in the cell. Acid precipitation refers to rain, snow, or fog with a pH lower than 5.6. Acid precipitation is caused mainly by mixing of different pollutants with water in the air and can fall at some distance from the source of pollutants. Acid precipitation can damage life in lakes and streams. At last, water as a transport medium for blood, in lymphatic system as lymph, excretory system, and digestive system. To summarize, water is needed by all known forms of life. Due to difference in distribution of charge, water, a polar molecule, hydrogen bonds hold adjacent water molecules together. Water has several important properties including cohesion, adhesion, and high boiling point. Water is involved in many biochemical reactions as a result. Just about all life processes depend on water. Thank you.
Thank you, Susan. That was an amazing presentation. So now, from this, we would have come to an understanding how the simple molecule called water is universally important for all the organisms with a diverse need. We have all read and we have really understood about the versatile and the adaptability property of water with its overall function over cell, with its chemical function, cell protein organization, DNA structure, etc. Not only this, this supports the basic property that how a water becomes a part of life as a molecule. So taking sips of water daily will keep us in a hydrated state and will not only improve our brain function, but also it will increase our memory power. Coming to memory power, does water has memory power? Or do you know a word called as memory of water? Yes, this theory was proposed in a lab, which was there in the late 80s, proposed by Jack Bentic, and later it was proposed by the UNESCO in 2014. The main objective of this water memory is a purported ability of water to retain a memory of substances previously dissolved in it, even after an arbitrary number of serial dilutions, so that water can carry information via an electromagnetic imprint from DNA and other molecules. So to support this, various other theories have been proposed and also scientific reports have been submitted regarding this topic. This was the latest update on this. And even PubMed has published an article in 2015 latestly on the memory of water. So thank you once and all for this opportunity. We'll go to the next presentation. Thank you.
Thank you, Susan, and thank you, ma'am. That was informative. And moving on to the next presentation by Dr. E. Emmy Goldie, second year PG student of biochemistry, under the topic of water and hydration, moderated by Dr. S. Ganeshan Sir, Professor and Head of the Department. Up to you, Madam.
Thank you, ma'am. Good morning, everyone. I'm Dr. Amy Goldie, second year postgraduate in the Department of Biochemistry. On this Water Day, my topic is and hydration. As we know, water is essential for life. Prevention of dehydration has been the major key to survival, even from the primeval times. Water represents a critical nutrition whose absence will be within days. Total body water is approximately 60% of the total body weight. Of 40% will be intracellular fluid and 20% will be extracellular fluid. Of which of extracellular fluid, 80% will be interstitial fluid and 20% will be plasma volume. Water intake will be equal to water output in order to maintain water balance. Some water loss will be there. It's called insensible water loss. It could be due to exertion, sweating, or fever, and compensated by fluid intake and water retention. Water balance is closely knit with the osmolality of extracellular fluid. Osmolality refers to the osmol per kilogram of a solvent. We can calculate osmolality by using the formula 2 into sodium plus glucose by 18 plus blood urea nitrogen by 2.8. The normal reference range will be 270 to 300 milliosmoles per kg. Regulation of fluid balance. Whenever there is a water deficient, there will be increased plasma osmolality, which stimulates the osmoreceptors in the hypothalamus, causing stimulation of ADH, anti-diuretic hormone, which causes water retention in the kidneys, and thus the water is conserved. It also stimulates the thirst center, leading to water intake. In cases of water excess, there will be decrease in plasma osmolality of anti-diuretic hormone. ADH in the collector acts via B2 receptors, which causes increase in cyclic AMP, which activates protein kinase to opening of aquaporin 2 channels. If there is any mutation in aquaporin 2 channels, will lead to nephrogenic diabetes insipidus. If there is any autoimmune destruction of hypothalamic cell or tumor or any trauma, will lead to central diabetes insipidus. We also have a condition called syndrome of inappropriate secretion of anti-diuretic hormone. This happens in condition like stroke or in lung cancer. Whenever there is a water balance, our body try to maintain the volume rather than concentration. So if we see the osmolality versus the volume, if there is an injection of isotonic saline, there will be increase in volume, whereas there will be no change in the osmolality. Whereas in injection of hypertonic saline, there will be both increase in volume as well as the osmolality. In cases of dehydration, there will be decrease in volume, whereas the osmolality will be increasing. Epidemiological evidence suggests that low water intake, low urine output, and high arginine vasopressin are associated with the risk of kidney and metabolic diseases. A key aspect to understand the relationship between water intake, hydration, and health begins with recording of fluid intake and its effect in population survey trials. Thermoregulation. A study say water loss via skin can range from 0.3 liter per hour in sedentary condition to 2 liter per hour in activity in hot climate. Intakes range from 2.5 to over 3 liters in adults under normal condition, which can reach to 6 liter per day with high extremes of heat and activity. Children and elderly have different response to ambient temperature and different thermoregulatory concerns than healthy adults. Effects of aging on fluid intake regulation. A study comparing water thirst and fluid ingestion response of older and a person show younger individuals ingest almost as much fluid than older person. This study also support small changes in the regulation of thirst and fluid intake with aging. Physical performance. During challenging athletic events, it is common for athletes to lose 6 to 10% of the body weight in sweat loss, thus leading to reduced endurance, increased fatigue, altered thermoregulatory capability, and reduced motivation. Rehydration can reverse this deficit and reduce oxidative stress induced by exercise and dehydration. Several studies show that performance in temperate and hot climate is affected to a greater degree than performance in cold temperatures. Cognitive performance. Dehydration can influence cognitive performance. In study conducted by Xian and colleague, mild dehydration produced in several important aspects of cognitive functions as in concentration, alertness, psychomotor skills, and short-term memory in children, young, and also in older adults. Conditions reverted on rehydration. Kidney in water balance. The kidney can crucially in regulating water balance and blood pressure, as well as removing waste from the body. Water regulation is hormonally mediated with the goal of maintaining a tight range of plasma osmolality between 275 to 300 milliosmol per kg. As we know, blood volume, blood pressure, and heart rate are closely linked. Blood volume is normally regulated by matching water intake and water output. In healthy individuals, slight change in heart rate, vasoconstriction acts to balance the blood volume. Water ingestion is also beneficial in preventing vasovagal reaction with syncope in blood donors. These effects of water intake on the pressure effect and heart rate occurs within 10 to 20 minutes of drinking water. Skin. The skin contains approximately 30% of water, which contributes to plumpness, elasticity, and resilience. Dehydration can be reflected as reduced skin turgor. Adequate skin hydration, however, is not sufficient to prevent wrinkles or other signs of aging, which are related to genetics, sun, and environmental damage. Patterns and trends of water consumption. ERSCO and colleagues spent a great deal of time working to examine all the sources of water in our diet. These create categories: the water that is found in food, the water that are added as a result of cooking, water coming from whole fat, milk, and juices, water consumption between meals. These studies suggest that we consume over 2100 ml of water per day, while those from European consumes less than half a liter or more. The effect of water consumption on overall energy intake. There is an extensive literature that focuses on impact of sugar-sweetened beverages on weight and risk of obesity, diabetes, and heart diseases. However, the percentage of providing more water and its impact on health has not been examined. In general, the result of this use suggests that water, when replacing sugar-sweetening beverages, is linked with reduced energy intake. Evaluation of the adequacy in water intake. Various markers have been proposed to assess the state of hydration, like plasma osmolality, urine specific gravity, urine osmolality, total volume of urine for 24 hours. Only 2 questionnaires have been designed to capture the usual beverage intake and were validated: beverage intake questionnaire and water balance questionnaire. The need further research is required maintaining the water balance. A Slovakian proverb says, "Pure water is the world's first and foremost medicine." Thank you.
Thank you, Amy. You have presented well regarding the regulation of water and its distribution, and how to measure osmolality, how to assess the body water level. Okay, good. We can go to the next topic. Yes. Thank you, Amy.
Thank you.
Thank you.
Thank you, sir. Thank you,
Thank you.
ma'am. For the last presentation of the day, I would like to call Dr. S. Balakrishna, a second year PG student of General Medicine, under the topic of Management of Dehydration, moderated by Dr. P.G. Shankara Narayanan, sir, Professor and HOD of the General Medicine Department. Up to you, Balakrishnan, sir.
Thank you. I would like to wish a very good morning to my professors and the Department of Biochemistry for providing me this opportunity in speaking in this forum. Today, we are going to have a small discussion.
1 minute,
Sir?
Balakrishna, on your video.
Okay, sir. Can you?
Yes, you can on your video. Your picture is not there.
Yes, I think my system did not show me this.
Okay, no problem. Proceed.
Okay, sir. Today we are going to have a small discussion about the management of dehydration and its medical aspects and how to approach the case of dehydration. On initial examination of a patient and evaluation, we have to approach a diagnosis towards what is the cause of dehydration. The most common presentation would be medical or surgical cause of dehydration. The medical causes would be vomiting or diarrhea.
Slide is not slide also not visible. Slides.
Yes, excuse me.
Hello.
Yes.
Hello. Sir, can you see my presentation screen, sir?
Previously it is seen, now it is not seen. Yes. Right.
Yes, sir. Okay.
Right.
Sorry for the disturbance.
No problem. Carry on.
Yes, sir. Today we are going to have a small discussion about management of dehydration. First of all, dehydration, we should decide whether it is a medical cause or a physical cause. The medical cause of dehydration will be commonly due to dehydration from vomiting, which causes loss of water, resulting in metabolic acidosis, or diarrhea, results in loss of water, sodium and potassium. But this tends to result in acidosis. The volume loss is severe. We should rule out any cause of gastric outlet obstruction or intestine obstruction, which results in third spacing, or in case of any pancreatitis, with a third spacing of fluid, and resulting in the fluid within the bowel loops. Other common cause of would be burns, results in loss of plasma and extracellular fluid from directly from the skin. The magnitude of fluid loss depends upon the extent and depth of wounds. Other cause will be sweating. This is in the from heavy exertion in the sun, or any athlete or any marathon sitting heat stroke. The most of the patients present to the any medical cause or surgical cause in any type of failure, they will be in a diuretic therapy with salt restriction. This induces a state of mild to moderate salt in the patient to keep water balance in a negative state, resulting in hypokalemia and hypovolemia, but with no clinical consequences. But this patient are prone to hypotension during the anesthesia of fluid loss. We should assess the past history of any given patient from any they are presenting with renal, cardiac, respiratory, or hepatic pathology. In case of any failure states such as renal, cardiac, or hepatic, there will be collection of ascites in the interstitial compartment. In case of any respiratory disease, there will be loss of fluid directly from the respiratory component due to patient will be in any respiratory pathology, including patient will be NIV or mechanical ventilation, or direct cough expectoration. This can contribute to the etiology type of fluid loss. First of all, the most common things are common. We should assess the cause of vomiting as a cause of dehydration in a vomiting condition. There will be results of water and sodium loss, which results in the activation of renin-angiotensin-aldosterone system, which results in increased sodium absorption. Sodium along with the water is absorbed from the renal tubule. The sodium is selectively absorbed from the renal tubule with selective from the sodium potassium transporter. The potassium will be secreted with the absorption of sodium. This results in hypokalemia. Because of dehydration, there will be increased absorption of bicarbonate, results in metabolic alkalosis. There will be loss of chloride and hydrogen ions, since the gastric acid contains hydrochloric acid, results in metabolic alkalosis with the hypokalemia and hypochloremia. The infusion of normal saline, 0.9% saline, corrects the volume loss with this patient, which results in decreased bicarbonate absorption. The sodium and the chloride, 154 milliequivalent per liter of normal saline, results in correct the sodium and the water deficit. The sodium supplement reduces the reduces the aldosterone secretion from the RAS system, and decreases the potassium and hydrogen loss from the distal tubules of the kidney. This corrects the hypokalemia, alkalosis, and dehydration. The other common causes are diarrhea. Rich in the gut loss of diarrhea causes loss of potassium and bicarbonate along with the water and the sodium. The loss of all four these vital electrolytes causes hypokalemia and acidosis. The acidosis is from direct loss of bicarbonate from the gut, and the excretion of bicarbonate with the chloride. This is in metabolic alkalosis. The loss of sodium and through the gut results in increased sodium absorption along with the chloride. This results in hypokalemia, hypochloremia, and metabolic acidosis. The treatment part of a diarrhea constitutes a ringer lactate and isotonic saline. Ringer lactate is the most physiological fluid. It also provides bicarbonate, which by conversion of it contains lactate and provides a substrate of bicarbonate to act as a buffer, hepatic conversion of lactate for the cause of acidosis. However, its potassium concentration is low and provides no glucose. The NS isotonic saline does not contain potassium nor any bases such as bicarbonate or any potassium to correct acidosis, but it provides water and sodium. Supplementation of bicarbonate and potassium is helpful in the treatment of diarrhea. It causes metabolic acidosis. Now we come to the clinical symptoms and signs in evaluating a patient of dehydration. Any patient of dehydration presents with excessive thirst with a dry tongue, decreased skin turbidity, restlessness, cold climate extremity suggests hypovolemia. The patient will have a partial hypotension or tachycardia, reduced urine output. In case of any edema and basal crackles or causes indicates water retention, JVP, CVP, and pulmonary vessel pressure can be measured in this patient. In assessing the severity of hypokalemia and hypovolemia, in children there is a state of no some severe. In adults there is mild to moderate severe dehydration, less than 2 liters, 2 to 3 liters, more than 3 liters. Mild increases thirst and urine concentration. In moderate, 2 to 3 liters of fluid loss in adults causes dizziness, weakness, oliguria, partial hypotension, low gravity. In a case of severe hypovolemia, there will be confusion so far. Systolic blood pressure less than 100. The patient will be in state of hypovolemic shock, slow, rapid ready pulse with a low pulse volume, cold extremity, capillary fill time is more than 3 seconds, and the reduced skin turgor. In this patient, if we investigate a person of dehydration, now the main important parameters in assessing this patient of dehydrated patient be hematocrit. In salt and water definition, hypovolemia, effective plasma volume decreases due to dehydration and hematocrit rises. The increase in hematocrit should be considered as a need for saline infusion. In assessing serum sodium concentration, such as serum electrolytes, in pure water depletion, such as in a state of diabetes insipidus, serum sodium concentration increases leads to hyponatremia. In a hyponatremia, in a euvolemic patient, without tachycardia or hypotension, that is when the patient with normal tensive patient with a hyponatremia is most commonly due to SAADH. Due to inappropriate secretion of ADH, in this patient, the patient will have a hyponatremia due to effective mild to moderate increase in intracellular volume. Mild to moderate increase in intracellular volume. The patient will have effective urine output of less than 1000 ml per day. We should rule out other cause of hyponatremia such as myxedema in hypothyroid patients, hypokalemia, glucocorticoid deficiency, and renal failure before diagnosing of SADH. Hyponatremia due to dilution in a edematous patient. And the rise in blood urine nitrogen and serum creatinine causes a state of prerenal failure in a dehydrated patient. Assessing the urine osmolality and the specific gravity in also aids in diagnosis. Urine osmolality is useful in differential diagnosis of both hypo and hyponatremia. In a hyponatremia, in a hyponatremia patient, usually the urine osmolality is low. If in a hyponatremia patient with the inappropriately high urine osmolality, think of SADH. In hyponatremia, the urine osmolality should exceed 600 to 800 milliosmoles per kg. If it is less than that value, you should think about diabetes insipidus. The specific gravity of 0.005 to 0.015 in a specific gravity of normal patient. If so, specific gravity of urine is increased due to amount of increased excretion of abnormal cells such as glucose, protein, radio contrast media, mannitol, and other things. The specific gravity of urine varies relatively in a predictable way with the urine osmolality. The urine osmolality in the urine osmolality investigation costs about 2,500 rupees in a normal setup. But if we are not able to perform that test, specific gravity of urine is in diagnosis of a patient. Urine electrolytes such as sodium, serum spot sodium. If the normal spot sodium is less than in renal hypo, normally urine perfusion normally is less than 40. In a renal hypoperfusion, it will be less than 20 milliequivalents per liter. Exclusions are renal salt-wasting diseases such as Bartter and Kittelman syndrome, adrenaline insufficiency, use of diuretic. The rise in serum sodium during a fluid therapy indicates the correction of renal hypovolemia, increases renal perfusion. And ABG is also essential in diagnosis of hypovolemia. 4 common conditions: metabolic acidosis, normal anion gap, low with the low pH and the low bicarbonate. The normal anion gap is 12. The causes of normal anion gap are hyperchloremic metabolic acidosis or diarrhea, as we discussed earlier, distal RTE. And high metabolic acidosis will include DKA in a sepsis or hypoxia patient, lactic acidosis, chronic dysphagia, and respiratory toxic. Metabolic alkalosis in the case of alkalosis due to vomiting or NG tube aspiration. Respiratory alkalosis and respiratory acidosis. Respiratory acidosis in a respiratory failure state. Respiratory alkalosis in the case of septicemia and hepatic failure. To arrive at plan of treatment in any given situation, answer to these 4 questions are needed. What imbalance are present right now, whether it is a deficit or excess are present now, and what is their magnitude, and what additional losses are expected during this treatment. In any treatment, we should consider about the side effects of the treatment, and we should account for that also. What are the daily fluid maintenance of the patient and the electrolytes? What are the problems with the patient? It gets maximum priority. If we correct the dehydration of the patient, and if we don't treat a patient of urgent necessity, such as there are some conditions which constitute a maximum threat to a patient life, such as in a treatment of shock, there needs to be urgent correction of intravascular volume. In case of any, in case of any hypovolemic shock or cardiogenic shock or a septic shock or an anaphylactic shock, we should account for that with mere presence of hypotension does not constitute fluid therapy. We should consider the cause of that shock and we should appropriate treatment along with the fluid therapy is essential. The correction of hyperkalemia is essential to prevent the risk of cardiac arrhythmia and sudden cardiac death. Correction of blood loss in a hypovolemic patient due to hemorrhagic loss. Avoid rapid correction in any patient due to any hyponatremia, hypervolemia due to the risk of cerebral changes in any dehydration or any overhydration. The cerebral site due to cerebral osmolality, there will be adapted to the condition. In case of any hyponatremia, there will be intracerebral dehydration. In hyponatremia, there will be cerebral edema. We should prevent that. Like a rapid correction should be avoided to prevent the risk of central pontine myelinosis. In overzealous correction of acidosis with bicarbonate carries risk of seizures because the rapid influx of PCO2 into the cerebrospinal fluid results in a case of acidosis. So, in case of direct bolus of bicarbonate is not indicated. In any case of bicarbonate process for desired bicarbonate concentration, we should always use bicarbonate with 5D and we should correct it over first 50% of values is corrected over 4 hours and the gradual replace of bicarbonate. We should correct the what are the cause of metabolic acidosis rather than the complications to prevent the further deterioration of the patient. We should assess the renal, cardiac, and hepatic status of the patient to minimize the risk of edema and ascites formation. This is the fluid guidelines of the patient in a patient with hypovolemia. The fluid selected for initial volume replacement in the patient hypotension due to his isotonic saline. Saline corrects hypovolemia effectively by replacing lost sodium and water. The colloids are preferred when hypovolemia coexists with hypoalbuminemia. But a single packet of 20% albumin costs about 5,000 to 6,000 rupees. But if a patient with hypovolemia, the albumin half-life is around 6 hours only. So it will retain a similar amount of fluid within the intraocular compartment. But we can give a repeated transmission of albumin causes autoimmune reaction to that albumin. For subsequent fluid therapy, selection of fluid varies upon patient to patient. In hypovolemic shock, a fluid bolus of 1 to 2 liters will be given within the first hour to restore patient with adequate tissue perfusion. Since dehydration causes dehydration of intracellular dehydration, which results in shift of intracellular acidosis and cellular extracellular damage and the cellular membrane integrity is also lost, which results in the further worsening of the patient. And adequate tissue perfusion should be maintained. If a prolonged persistent hypotension patient with a reduced intravascular volume and intracellular volume, the cellular damage will be greatly increased, results in a multi-organ dysfunction. The average fluid aim of fluid therapy is not administered mere fluid, but induce a positive fluid balance. In every episode of diarrhea, the patient lost around 300 ml per fluid per hour. Diet fluid increased at a similar rate, there will be no correctional fluid deficit. On the contrary, if the urine output and insulin loss are not concerned, in spite of infusion of fluid, the fluid deficit will worsen. So we should account for that loss and account for reducing fluid loss and ongoing losses. So effective rate of fluid replacement is 50 to 100 ml per hour with the urine output per hour, with the loss of outgoing loss, such as the diarrhea or drain tube, in case of any fistula drain tube or any case of ICD drain tube or in case of intraperitoneal drain tube or NG tube per hour, output should be considered in a fluid replacement therapy. If we follow these assessing the patient clinically and with the help of, should assess the patient clinically with the help of laboratory parameters, we should, if the patient responding to our fluid therapy, how the patient is responding to our treatment would be the regaining weight due to weight loss, due to fluid loss. The skin and the tongue will become more warm extremities and the normal skin elasticity will improve. The sensory of the patient will improve and the patient will have reduced anxiety and restlessness. The urine output will increase 30 to 50 ml per hour in adults in the absence of renal glycosuria or osmotic diuresis. The increased urine output with the decreasing urine specific gravity and osmolality or other dependable parameters. The correction of tachycardia to a pulse rate of less than 110 in young adults, as well as a change of pulse volume from low collapsing pulse to a bounding pulse indicates the patient is responding to our fluid therapy. We should account for the cause of hypovolemia within the patient. We should account for what is the type of fluid loss, or how is the patient requiring. In case of any third spacing or any overloaded state, such as any cardiac, renal, or hepatic fluid state, the patient will have adequate insufficiency or overloaded state such as chronic kidney diseases due to loss of reduced secretion of fluid, or in case of any cardiac pathology due to right heart failure, patients unable to maintain effective intra-circulating volume due to a cardiac failure. We should account for that also. The help of appropriate measures in case of any inotrope support in the patient of cardiac pathology, or any dialysis, or any case of diuretics in case of chronic kidney diseases, or in third spacing in case of intra-abdominal pathology in surgical causes, or pancreatitis, or in case of any hepatic insufficiency, account for reduced osmotic pressure with supplement of albumin, high protein diet, with use of aldactone or other drugs. In a blood pressure in the patient shock will improve, and the normal from hypotension and orthostatic hypotension patient become normotensive. The decreasing hematocrit is the absence of hemolysis or actual blood loss. The patient hematocrit will decrease. In case of any with the decrease, in case of any dehydration, the hematocrit will rise. The hematocrit will fall in a patient with the hemolysis or a blood loss. Patient account that for also. The blood urine nitration serum creatinine ratio will follow. The prenatal failure will open up with case of diuretic. The increased urinary secretion of sodium per hourly per liter improve. Urinary sodium remains under 25 milliequivalent. The kidney is sensing persistent urine volume depletion, and the patient has additional fluid replacement. The sensing of renal osmolality is present within the extracellular apparatus. The kidney will sense the fluid and electrolyte imbalance within, and normal physiological and negative feedback mechanism will follow. The metabolic acidosis, improvement of acidosis with improved peripheral perfusion corrects the metabolic acidosis. The central venous pressure and the pulmonary vessel pressure will become normal with adequate fluid replacement. So I would like to thank for providing me this opportunity. Thank you, sir. Thank you, ma'am.
Thank you, Dr. Balakrishna. First of all, I'd like to thank my classmate, Professor Ganesan, for organizing this World Water Day webinar to enlighten about the importance of water. We have seen almost in everywhere they organize similar program in their own field. Sir, you organized importance of water in our medical field. Our postgraduate done well, but very elaborate presentation. The presentation should be up to for the audience, and you should present slowly. You no need to be in hurry, and of course by this time every audience will get dehydrated or after say listening your presentation. Okay, anyhow, it is a nice presentation. I said the hydration, electrolyte imbalance is very, very important, as all of you know, especially diarrhea, vomiting in this hot summer, ensuing hot summer. In our days, in our house agency period, we have seen a lot of death due to diarrheal diseases. But of course, after proper education, proper protected water supply, and availability of ORS salts everywhere, and public education. So we are getting less number of cases, less number of death, especially in infants due to diarrhea and dehydration. I once again thank my classmate, Dr. Ganesan, for organizing this webinar. Thank you one and all. Thank you, sir.
Thank you, sir.
Thank you, Shankar. Thank you. Thank you very much.
Thank you. Thank you.
Before winding up the session, I would like to invite Dr. M. Nasiran sir Assistant Professor at the Department of Biochemistry, to deliver a vote of thanks. Over to you, sir.
Yes, good morning to all. On behalf of Lakshmi Srinivasan Medical and Hospital, I take this opportunity to propose a vote of thanks to those who have directly and indirectly contributed to their work and their presentation to this on water organized by our Department of Biochemistry, ESMCH. And all the outset, I thank our resource person. We are really enlightened with your knowledge and presence. We are thankful to our institute and their founder, chairman, and vice chairman for their motivation. And I would like to thank our dean for her all-time support. Special thanks to organizing committee, both teaching and non-teaching staffs for unflinching support and their coordination. Our heartful thanks to our students, undergraduate and post residents for their active participation. And with these warm words and a kind message, we move on to the end of the today's session. And once again, I thank you all. Thank you. Thank you.
Thank you. Thank you, sir. Thank you, everyone. Thanks for the participation.
Thank you, ma. Thank you, ma. Thank you, ma. Thank you.
You can leave, sir. Thank you.